Hello and a heartwarming wabba-labba-dub-dub to you. Welcome to the latest episode of myCTalkthroughs, and today we are talking about arrays, especially about initializing arrays. If you define an array in C, the memory required for the underlying data type is reserved and made exclusively available for storing values of your program. Yeah, but much more important, however, is what does not happen. No zero values are written for the corresponding data type. Values in memory cells at the time of the reservation are accepted without any further notice. Sometimes these values may be zeros, sometimes remnants of previously executed programs, or depending on your operating system as well on your programming environment, simply nothing like white noise. The inconvenient truth is that you have practically no influence on it if you don't roll up your sleeves and set them manually. Basically, don't rely on what is given to you without first reading the terms and conditions, meaning here that you know exactly what is going on. For this reason, it is necessary and should be second nature to you to initialize each variable, to declare it and assign an initial value as soon as you call the variable into existence by its identifier. And this can be done quickly for a single variable, but for an array, perhaps even a multi-dimensional array, it requires a certain amount of effort. However, the C programming language, and in particular the compiler used, will help you with that work to a certain extent. In this video, we take a look at the possibilities of initializing arrays with the GNU compiler collection GCC with other C compilers such as Clang, or the latest, then the last of the following example, that may not be feasible. The compilers may offer other options though. So what we have here is a little example I already prepared for you, and if you want to declare an array in C, you usually do something like this here. You have to declare the underlying type as well the identifier of your array, followed by squared brackets with a number in it. And if you do so, what you will get is basically something like this. And the line 8 and 9 I only prepared here for output. So if you compile and run this here, then you will get some result like shown here in the terminal window. 0, 0, 0, 0, 0, 0. That looks great, and you may or may not see zeros for the initialized for the not initialized elements. Also, your compiler and its settings or IDE may or may not be available of the situation. In doubt or in need of ensuring rock solid determination of values, you have to set them manually. Look here in the compiler in the build log, build messages. You can see here, unfortunately in blue, some warning. And the warning is that on line 9, numbers may be, we want to print out at that point, may be used uninitialized. So the compiler here gives us a warning that they may be uninitialized, but it does not actually initialize that value for our array numbers. And as you can see here in the square brackets, we for each element we count an absolute number, here 6, or you can also keep this empty. So if you keep it empty, then you need to give the compiler the chance to determine a specific number. In that case, you have assigned directly the number of elements by putting in some numbers. And you can do that easily just by following with some curlies. And for example, I will add now here several numbers. And as you see, if you do this here and you run the program now, then it should work this time and show you a picture like this. So I let out the number of elements I want to put in here. Instead, the compiler sees 1, 2, 3, 4, 5, 6 elements are assigned, or values for 6 elements are assigned. So the compiler automatically allocates array storage for the 6 integers shown here. And you should also declare the array, and so you could also declare the array and assign the values separately. You don't need to do that in one line as shown here. And I also want to show you an example for that. It's very simple to do so, but usually, if possible, try to automate that assignment in a for loop. And that is also kind of trivial. So I remove this now here again and put in a specific number of elements here. And before outputting the whole thing, I will put in 2 lines of code here, which fill the array, with the number 10, 20, 30, 40, 50, 60. It is an assignment separated from the declaration, and this 3 lines together make the full initializing of the array. We also want to run this code quickly and demonstrate that you get to the same result as before. This is a very common way to initialize your arrays in C. But in case the array has storage for 6 elements, but you want your code to initialize only the, let's say, 4th and 5th element, you can do something like this here. I also copy paste that. So what you see here is I initialize an array with 6 elements, and for the number 3, so the 4th element, and for the element with an index 4, so the 5th element, counting starts with 0, I want to initialize the values 40 and 50. So also this we quickly compile and run, or I have to close the terminal window first. And as you see here, what we get now here is 0, 0, 0, then a 40, then a 50, and another 0. Brackets with the element number and the assignment of specific elements work quite well, but you don't have to rely here on the zeros. If you use this you have to use this with caution. The remainders of the array's elements are not exclusively initialized. That is a pure by chance 0 here. If you, I can really not get tired of emphasizing this. The zeros you see here, you can't rely on. You have a fair chance of getting zeros, but as a word of quantum level values of the quantum field, or not, these values are not fully determined. The probability function collapses when executing the compiled code, so to say. Yeah, but if you have only a handful values, you can initialize your array in one step, similar like the one I will show you here now. If you have only a few values, you can do something like this here. We have seen already something like this with 10, 20, 30 and so on, but here just to have something different. And we already saw the result. Basically, you get the numbers here and everything looks fine for you. But if you do not provide enough values to the compiler to fill this up, then again, if you execute this, you get zeros here, but again, these are not real zeros. The element number 4, 5, and 6 are nothing else but with garbage filled values. If you want to initialize your array with 0 values, so only with 0 values, and please be aware that the following example works exclusively with zeros only, then you can do something like this here. If I put in a single 0 in the curly brackets here and to run this, then you will see that what you get is a 0 value for each, and this time it's fully determined. You don't need to worry. This works with practically every compiler I ever have used, and this is an option to fill up and initialize an array with zeros. So this works. That is nice to know. And a declaration of an array and setting the values can also be done in one step, even for a multi-dimensional array, under the condition that the array's values are stored in a row-wise manner. So what does it mean? What you can do is you can put values for a 2-dimensional, here 3 and 3-dimensional array into one row. If you do so, then of course, if you want to print that out, you have to do that some different. In this case, I want to show you how I will do that here. So, I know that not. So here you see I go into some nested for loop, and that nested for loop goes from 0 to 3 or 0 to 2, and here also from 0 to 2. So 3 times 3 elements are shown here, and if you do so, the result looks like this here. And as you see, 1, 2, 3, 4, 5, 6, 7, 8 and 9 are assigned here, and then output. What you have to keep in mind, you see that the order of reading from one row determinates the length of the row, respectively the width of the column. So one or the other dimension. Most C programmers keep their 2 or sometimes more seldom three-dimensional arrays as one row in their minds as well in a table-like design flow. And now I would like to show you some GCC exclusive ways as an extra to determine some values. And to do so, first of all, we will I want to erase this here from the code and put this here into action again. What you can do with an integer array, let's say of 9 elements, is within the curlies you can use for assignment square brackets. And I can now, from the 0, element number 0, so from the first element with 3 dots, to the 8th, or element number 8, so the last element, assign a 10 here. You have to be careful. It is important, it is mandatory that you use a white space here. Don't forget that, else it will be interpreted as a decimal point. And then the compiler will throw an error anyway. But if you execute this, what you really get now is a 10 for each element. So it's fully determined what you get here. All elements of the array are initialized with a specific value this way. And you can even drive this over the top by combining this with a list of element values you like to set. You can do that, something like this, for example. First element, I want to be a 23, divided or separated by a comma. And this time I want only the second element and the second last element be a 10. And the last element I want to be a 42. So let's try this also. And the result you see here, 23. Then the elements in the middle are tens. And here something went terrible wrong. Probably because I output not enough of the elements. So here I have to go below 9, because I have 9 elements, and I have to count from 0 to 8. And if I now execute this again, you see that this time you see the full array, 23, 10, 10, 10, 10, 10, 10, and 42. Yeah, that is a very useful way in many cases to initialize your arrays. And once you got used to this notation, you don't want to miss it anymore. So, install your favorite C compiler, set up your IDE, and just do some simple experiments. I wish you good times for that. And don't forget, time spent learning something new is never wasted. So, see you in the next myCTalkthroughs.